Hello, in the second video we're going to be introduced to another family of hydrocarbons. So we came across the alkanes that have the general formula CnH2n plus 2, and now we're going to have a look at what distinguishes the alkenes. So we're going to carry on with the table and let's get going. Okay, so now that you understand how the alkanes work, the alkenes should hopefully take less time to understand. Now, because the alkenes also have carbons and hydrogens, we're going to use the same pattern for naming them. So let's just remind ourselves: meth, eth, prop, bute, pent, hex, hect, oct, non, dec. Can you do it backwards? Dec, non, oct, hex, pent, bute, prop, eth, meth. Okay, right. Now the good thing is, for the alkenes, all we're going to do is we're going to end these in ene. So we're going to have pent-ene, hex-ene, non-ene. Get the idea? Really quite simple. Okay, and we're not going to use this one, and I'm going to show you why in a moment. Right, so the distinguishing characteristic of the alkenes, I'm just going to remove these out the way for us. The distinguishing feature of the alkenes is that they have a double bond. So what do I mean by that? So if I take my marshmallows, let's do this first. So here's my marshmallows, and I have got 2 carbons, and this time there is one double bond between the carbon atoms. Okay, there's my double bond. So if you remember, each carbon can only have 4 bonds. So this one already has 2, 1, 2. So I add in 3, and let's get one that's slightly longer, 4. Okay, and then on this side, this carbon atom has already got 2. Try it like that. 1, 2. So I add in the 3rd and the 4th. So that means if I add on my marshmallows, 2, 3, and 4. So what we have over here, 2 carbons, 1, 2, 3, 4 hydrogens. This is ethene. Okay, so let's go back to our sheet and let's draw that in. So ethene. Because we have to have a double carbon bond, we are not actually going to have an alkene with 1 carbon, because you need a double carbon bond, so that's not going to work. So we start off with over here, and we're going to call it eth, this time ene. Okay, in our structural formula we had a double carbon bond. That carbon has already got 2, so we add on the 3rd and the 4th bond, and we add a hydrogen to that. And this carbon has already got 2 bonds, so we add on 2 hydrogens. Now it doesn't matter if you draw it at the top and the bottom. I just generally just like to draw it like that. It's how you see it in a lot of textbooks. So the formula for ethene is C2, 1, 2, 3, 4, 4 H's. Okay, getting the idea. Pretty good, isn't it? Now let's have a look at number 3. What's the number 3 jersey in a rugby? Yes, it's the lovely prop. Propene is going to be our next one. Propene. Okay, so let's make a molecule of propene. So this time, if I take over here my 3 marshmallows. Now 1, 2, and 3. Now, this is where you've got to be a bit careful, because this is where sometimes people start going a little bit wrong. In the alkene, there's only allowed to be one double bond between the carbon atoms. So I could decide my double bond is going to be between those two, or I could decide it's going to be those two. Just for the heck of it, I've decided that my double bond is going to be between the second and the third one. Okay, so now let's add on the hydrogens. So I'm going to make sure that my pasta isn't too short. So what I'm going to do, this carbon already has 2 bonds, so I've got to add on the third one over there, and I've got to add on the 4th one, like that. Okay, then this carbon here, how many bonds does it already have? Let's count. 1, 2, and 3. So it only needs 1 more hydrogen. Now I can decide that hydrogen is going to go at the top, or I can decide it's going to go at the bottom, and for now let's make it on top of the world. Okay, right, and then for our final, let's just double check. 1, 2, 3, 4. So that one has got everything it needs. Now this carbon atom has got 1 bond, so I've got to add on 2, 3, and 4. Okay, so getting all my pink marshmallows. I don't know how my kids are going to feel about getting a whole bunch of holy marshmallows, but you know, there we go. So we have got, in total, let me just adjust that camera so you can see I'm not cheating. So we have got 3 carbon atoms, okay, and then if we start counting in one place, 1, 2, 3, 4, 5, 6 hydrogen atoms. So 3 and 6 means that however many carbons I have, I just double the amount of hydrogens. Cool, isn't it? Let's go and put this aside and let's draw this. So for propene, I'm going to draw my 3 carbon atoms. Somewhere, because it's an alkene, I have to have a double bond. Now if you look at the word alkene, there's 2 E's over there, E and E, and that reminds me that I have a double carbon bond, but only one of them. Okay, so that one has got to have a single bond, and I now add on 2, 3, 4, 3, 4, 1, 2, 3, 4. So if I put in my H's, and I'm going to this time C3H6. So let's do one more before I leave you on your own to do it by yourself. So for the alkene, and it might be worth, just to make sure you don't get yourself confused, I'm going to just draw a double line over here to separate these 2 families. So the next one, meth, eth, prop, 4 butenes, B-U-T-E-N-E. Okay, so I'm going to have my 4 carbons, and somewhere, anywhere, I need a double bond. I just feel like putting it in the middle. So the others are going to have a single covalent bond. Now it's just about counting, okay? And this is how you know that you're right. Again, one of those wonderful things in the exam, you know whether you've made a mess up and you need to fix it. That carbon now has 4 bonds. That carbon over there has got 3 bonds, so I just need to add on 1 more. Top or the bottom, doesn't matter. That one has already got 3 bonds, so I just need to add on 1 more. And this carbon has got 1 bond, so I need to add on 2, 3, and 4. Making sure they're all in the same color. And then I can double check in another way that I haven't made a mess up by counting the number of H's. I've got 4 carbons, so I expect double 4 is 8. 8 H's, 1, 2, 3, 4, 5, 6, 7, 8. Perfect. C4H8. So the general formula for every carbon I have, however many I have, I take the number of hydrogens and I double it, 2n. CnH2n. Let me just do it in the same pen. 2n. Okay. Now, we need to know the test for the alkenes, because if I have ethane and ethene, how can I tell which one is which? Well, there is a wonderful way of doing this. Excuse me. So, the test for this, just like the test for carbon dioxide is add lime water and it turns cloudy, the test for an alkene is this. I add bromine water. Now, we know that bromine has got a double Br because it is a diatomic molecule, and it shares a single pair of electrons, so it's a single covalent bond. Now, what happens, if you can imagine, if we did this in class, as an alkene, I would make you hold hands with the person next to you, so you're holding 2 hands, okay, rather than holding one hand with one person, one hand with the other person. Now, let's just say you're holding a hand with somebody who's got really, really sweaty hands, and now both your hands are getting sweaty, and it's like, oh, I don't want to hold hands with that person. Now, if bromine comes along, you've got the opportunity to let go and join on with the person next door. So this is exactly what happens. When bromine comes along, this ethene molecule is going to go, yes, I can let go of that double bond. Still got to hold on with one, but I'm going to pick up the bromine, one of them at least, and I'm going to form that. And so what happens is the bromine water that I added, which was originally an orangey brown color, because the bromine's becoming part of this now, it loses that orangey brown color and it becomes colorless. Whereas if I'd added bromine water to ethane, it would have stayed orangey brown, because these single covalent bonds between the carbons, they don't want to let go. They don't want to let go. We say that these molecules, because they have the maximum amount of hydrogens attached to them, whereas these have less hydrogens because of the double bonds, that helps me to remember that we describe the alkanes as being saturated. They are saturated molecules. And the alkenes, by contrast, they're a little bit unhappy because they're having to hold hands with somebody with sweaty hands. Ugh. And they are unsaturated. Unsaturated. So double bonds are unsaturated. Single covalent hydrocarbons are saturated. Okay, so make a note of that. And what I would love you to do is I'd like you just to add, perhaps in a different color, the chemical test. Okay, so the test is that I add bromine water, which is orange, and it goes colorless. Oh, L-O-U-R, colorless. I know I'm squeezing it in there. Bromine water goes from orange to colorless, where over here bromine water stays orange. Okay, so what I'd like you to do is I'd like you to draw all the alkenes for me, including the structural and the molecular formula and the name up to 10. Once your table is completely finished, you are done. And you can eat your marshmallows. Good luck. What I'd like you to do is I would like you to, this week, take a photo